Welcome to the deep dive. So today we're kind of taking a big leap, looking beyond the edge of our own solar system and pondering something pretty fascinating. Could some of the objects we see, whizzing about actually be travelers from another star? It sounds like sci-fi, but well, it's not entirely.
No, exactly. It's a really mind-blowing idea, but we know interstellar objects are out there. We've actually seen a couple pass through. ʻOumuamua was the famous one.
Right.
But the big question has always been, okay, where exactly are they coming from?
Yeah, the origin story. And that's where things get really interesting now, isn't it? There's this new research we've been looking at, just published actually March 6th, 2025 in the Planetary Science Journal. It's from Cole Gregg and Paul Wiegert at Western University.
That's right.
And they're making a case that our nearest neighbor, Alpha Centauri, might be, well, a source.
It's a really compelling study. They're not just saying, hey, look, another interstellar object. They're digging in the how and the why. How could stuff get from Alpha Centauri to here?
Okay, so before we dive into their system, maybe just a quick refresher. What exactly makes something an interstellar object?
Good point. So basically, it's any bit of astronomical material. Could be like an asteroid, could be like a comet that isn't gravitationally tied to a star. It got kicked out of its home system somehow and is now just drifting between the stars.
Got it. Ejected. Free-flowing space stuff.
Pretty much, yeah.
So Alpha Centauri, it's not just one star, right? It's a triple system. How could that system send objects our way?
Okay, so this is where Cole Gregg's computer modeling comes in. It's quite sophisticated. He basically simulated the interactions between our solar system and Alpha Centauri, looked at how material might move between them.
Like dust and gas, or bigger things?
Both, really. But the focus here is more on the larger chunks of potential asteroid or comet-sized objects. And crucially, the model applies physics we understand from our solar system, like how planets interact with smaller bodies, to the more complex dynamics you'd expect in a three-star system like Alpha Centauri.
Right, because in our system, planets like Jupiter can cause, well, chaos, right? They fling things around.
Exactly. That's a perfect analogy. Our giant planets have these huge gravitational fields. They can seriously mess with the orbits of smaller objects, asteroids, comets. Sometimes a close flyby gives a smaller body such a kick, such a speed boost, that it just escapes the sun's gravity altogether. Whoosh! Out into interstellar space.
Okay.
So Gregg's model assumes something similar is likely happening over in Alpha Centauri. Their planets, whatever they might be, are probably doing the same thing, causing gravitational disturbances, slingshotting material out of their system.
And they simulated this, like how fast things might get ejected.
Yeah, they ran simulations with different ejection speeds to see what was plausible and what might actually make the journey over to us.
So the million-dollar question, or maybe the million-object question, if Alpha Centauri is ejecting stuff like our system does, what are the numbers? How many of these interstellar travelers might actually be, hanging around near us?
Well, this is where it gets pretty wild. Based on their simulations, they estimate that right now there could be about 1 million objects from Alpha Centauri, bigger than 100 meters across, currently inside our Oort Cloud.
1 million. In the Oort Cloud. Wow. Okay, remind us what the Oort Cloud is again.
Right. So the Oort Cloud is this theoretical, massive spherical shell of icy objects, mostly comets, way, way out. It surrounds our entire solar system, like incredibly far out. Is the deep freeze, the boundary region.
So 1 million potential Alpha Centauri immigrants hiding out in our solar system's attic, basically.
That's one way to put it, yeah. And if that number is even close to correct, it says a lot about how common this ejection process might be.
Hang on, didn't you say Alpha Centauri is moving? It's getting closer to us?
That's another key part of this, yes. Over vast timescales, the stars shift relative to each other. Alpha Centauri is currently on a trajectory that brings it closer to our solar system. Their models predict its closest approach will be at about 20,000 years.
28,000 years. Okay, not exactly next Tuesday, but on a cosmic scale.
Exactly. It's relatively soon. And as it gets closer, the thinking is that the number of its ejected objects reaching our Oort Cloud could actually increase.
That makes sense. Shorter travel distance, higher probability.
Precisely.
It's probably worth mentioning, too, one of the researchers, Paul Wiegert, he's got serious credentials in this area, right? Discovered a lot of asteroids and things.
Oh, absolutely. Professor Wiegert is very well respected. He's discovered, I think the number's over 80 minor planets, asteroids, near-Earth objects. So yeah, his expertise in tracking and understanding how these small bodies move is definitely a big asset here.
And speaking of finding things,
his work really provides a solid foundation for thinking about how objects might arrive from outside the solar system. And it's kind of fitting, actually, because the very first confirmed interstellar object, ʻOumuamua, that was found back in 2017 by Robert Warwick, also from Western University.
Ah, right, the connection. Oh, that was the really weird one, wasn't it? Long and thin, reddish.
Yeah, very unusual shape, unlike typical asteroids or comets we see. Its estimated size was pretty significant, too. Estimates ranged, but maybe 100 meters up to even a kilometer long, and much thinner, maybe 35 to 170 meters wide or so.
So the million objects they're talking about from Alpha Centauri, they're potentially in that ballpark, size-wise. Bigger than 100 meters.
That's the threshold they used, yeah.
Yeah.
Objects larger than 100 meters. So potentially comparable to ʻOumuamua, or at least not just dust specks.
Okay, which leads to the inevitable question. A million objects, potentially large, hanging out in the Oort Cloud. Should we be worried? Is any of this stuff likely to come closer and cause trouble?
It's a natural question, definitely. And the model does look at that. It predicts that, yeah, some tiny fraction might make it all the way into Earth's atmosphere. They estimate maybe up to 10 meteors per year could originate from Alpha Centauri.
Okay, 10 per year.
But, and this is the really important part, these would be absolutely minuscule. We're talking sizes no bigger than 100 micrometers.
Micrometers, how small is that?
Like the width of a human hair. Tiny dust particles, basically.
Ah, okay, so definitely not Armageddon-style asteroids.
No, absolutely not. These tiny specks would burn up completely harmlessly in the atmosphere. They pose zero danger.
So it's more like we might be breathing in microscopic bits of Alpha Centauri dust eventually.
I mean, theoretically, maybe.
Okay.
But even then, the numbers are incredibly small compared to all the other dust hitting Earth. Their calculation suggests only about 1 in a trillion meteors hitting Earth might actually be from Alpha Centauri.
1 in a trillion. Okay. That puts it in perspective. The odds are astronomically low, literally.
Very much so. Most of these objects, if they're there, will stay way out in the Oort Cloud or just pass through the inner solar system unnoticed.
That's definitely reassuring. So zooming out a bit, what's the bigger picture here? What's the main takeaway Cole Gregg emphasizes from this work?
Gregg really talks about this idea of interconnectedness, how we need to maybe rethink how we view star systems. You know, historically, we thought Earth was the center, then the sun, that our solar system was this isolated bubble.
Right, self-contained units.
Yeah. But this research paints a picture where the galaxy isn't just like a collection of separate systems. It suggests it's more dynamic, more interactive. Star systems might actually be sharing material, sending stuff back and forth.
Like cosmic neighbors borrowing cups of sugar, but the sugar is asteroids.
Sort of, yeah.
Yeah.
A constant, slow exchange of material across interstellar space. It's a fundamental shift in perspective, really.
It really does make the galaxy feel a bit more connected, less like isolated islands. And just for listeners who want to read the paper itself, it's a case study of interstellar material delivery. A Centauri. Gregg and Vigert. Planetary Science Journal.
That's the one. So, summing it all up, we've got this compelling case for a link between us and Alpha Centauri via interstellar objects. Millions might be out in the Oort Cloud, but the actual risk to Earth is, well, practically zero based on this model.
Right. Tiny dust, not giant rocks.
Exactly. But it does raise fascinating questions, doesn't it?
Huh.
About how accurate these models are, what uncertainties remain, and how common this exchange really is between all stars.
Absolutely. It makes you think, if we're potentially swapping material with our nearest neighbor, what other connections exist out there across the galaxy that we haven't even considered? And, you know, as our telescopes get better, our models get smarter. How is this going to change our picture of, well, where everything in our own solar system even came from originally?
It's a huge question.
Definitely something to ponder next time you're looking up at the night sky. It makes you wonder what else is drifting out there. Thanks for taking this deep dive with us.